Okay, so question 3 is on simple harmonic motion, and the first question has to find the frequency, which is 1 over the period. So if we take another look at the graph, see the period is the time for one full oscillation, so your 2 points there, which we can see is about 2.4, so it's just 1 over 2.4 there. And then for part 2, we're asked to work out the maximum speed, which is 2 pi fa, so using the frequency from the earlier question. And then for the amplitude, we're looking at the maximum displacement, which is here, and we can see it to be about 50 times 10 to the minus 3. So just putting that into the equation to get 0.13. So in part B, we're asked if the displacement is changed to 25 millimeters, which is just half of what we had before. What changes are going to be made firstly to the frequency? So in SHM, the frequency is independent of the amplitude, so that's going to stay the same if you change the displacement. And the maximum kinetic energy, so the maximum velocity is reduced because the maximum amplitude is reduced, and the maximum velocity is proportional to the amplitude, and so EK max is proportional to a squared, so if that's halved it will reduce it by a factor of 4. Right, so now we're given a graph which is relating acceleration to displacement, and firstly we're asked to show how that graph shows that it's undergoing simple harmonic motion. So firstly, the straight line through the origin is showing that acceleration is proportional to displacement, which is a feature of SHM. And then the negative gradient is showing that the acceleration is always away from the displacement and towards the equilibrium position. So lastly, we're asked to determine the frequency of the vibration. We've got that acceleration is equal to minus 2 pi f squared. And if we relate that to y equals mx, we've got that the gradient is equal to minus 2 pi f squared, which you can read from the graph to be 5 over 0.004. And if we put them equal to each other and some simple rearranging, we get that it's equal to 5.6.